Our next speaker is Anurag Ambedkar, Vice President of International Business, Maven Systems. Maven Systems recently got acquired by MOSchip. And his talk is going to be centered around IoT for businesses. It's a short survey of technologies and very, very specific case studies. So welcome, Anurag.
Great. Very good morning to all present here. I'm Anurag from Maven, a MOSchip group company. So at Maven, we are a focused IoT product and solutions company, enabling IoT solutions into a variety of industries as an end-to-end solution. Okay? To give you a snapshot, we started deploying our solutions since 2011, and today we are monitoring and controlling more than 50,000 devices on the field. Okay? Coming to the presentation, we would speak and focus on IoT for businesses. My presentation would have two parts. The first part focusing on most prevalent and used IoT communication technologies. The objective is to help business decision makers here to make a decision on selection of a right technology for an application case. Okay? The second part, we would look and dwell more into actual real-world implementations and case studies of these technologies onto the field. So these are some of the prevalent IoT technologies. What you can see is short-range technologies like Bluetooth, mid-range technologies like Zigbee, sub-1 gigahertz, 6LoWPAN, and wide-area network technologies like LoRa, GSM GPRS, WiMAX, the long-standing partner Ethernet. Let's get into details and have a bit of snapshot of each of these. So iBeacon Eddystone, a battery-operated device for short range, suitable for application cases where you have large number of devices to be monitored, hence a low cost, right? A very critical characteristic of this technology is it has a connectivity with the mobile. Hence, mobility is at par. Typically used for application cases like asset monitoring. Here is a case study. So speak with an administrator of an hospital, and he would tell you it's a nightmare to track where are my wheelchairs, where are my assets, which are high-valued and portable equipments. Same would be a response coming from an administrator of a retail chain, right? Application of iBeacons here helps you have a quick control on the overall management and asset tracking of such kind of assets, okay? Moving further, there are application cases where you need to communicate and have multiple sensors to get in field data. So you need two-way communication. A choice of technology there would be a Bluetooth low energy, okay, which would have battery-operated capabilities, would be able to also communicate with your mobile. A quick example is a temperature-operated BLE tag. This is a tag that we designed for one of our customers, wherein it monitors the vital parameters of a patient, is attached like a tag, a nicotine patch, communicates with the mobile. Through the mobile, the data goes to the head end, which has analytics, which helps into creating actionable data for the required stakeholders, a medical practitioner, right? Other application cases, I'm sure most of us here use a Fitbit. It's an application case of BLE. A very commonly used term, Zigbee. An important characteristic of this technology is, one, it is interoperable. Hence, can work into applications where you have multiple third-party equipments and want to have a single dashboard control for all of them. Number two, it has mesh networking capabilities. Hence, is suitable for applications which need a larger coverage. Okay? These are the examples. So a lighting automation case, wherein you have a large coverage to be monitored. Hopping of data via a mesh network is what helps you. The moment you have a control on every individual light, you can do energy savings, right? A typical case, more relevant to interoperability piece that we were speaking about. You have multiple equipments in a home, HVAC, your light, your other devices in the home, and you want to have a central dashboard control over a user touchpoint like a mobile or any other device. The right choice of technology for interoperability there would be Zigbee. Now getting to some of the wide area network technologies. LoRa is one of the most heard of topics into the IoT, right? A technology which is for long range communication, suitable for battery operated applications. Most important piece is it is suitable for application cases where you have to transfer very minimalistic amount of data, not huge bandwidth data, right? Application cases could be into industrial IoT as well as agriculture. WiMAX, well known, suitable for high bandwidth, high data, high range applications. Typically applications like security surveillance. This is something that each one of us has been working on for a long time. An important characteristic of a GPRS, GSM, 3G, 4G enabled solution is it needs a lot of power. Hence is more suitable for application cases where there is AC power available. A typical case could be a BTS shelter monitoring application. Right? Now getting to the case studies. We would start with some of the application cases in industrial IoT. Okay? Well, all of us have been working on industrial IoT, hearing, talking about it, trying to exercise our gray cells of what could be done. Here are some of the cases that we thought are relevant, and most of them are cases that we have been working on. Okay? A typical problem statement on the production floor is wherein you do not know what is happening with the items that are in production. There is wastage, there are losses. The production manager doesn't know where are the wastages happening. He doesn't have a track of it, right? A simple IoT-based solution with something that we talked about, like an iBeacon on the asset, can help reap benefits related to tracking the in-production devices, hence save you cost. Save cost of inventory by just-in-time manufacturing capability, right? Also help you improve productivity of the overall plant because you know where your manufactured component is at what time, what is the time spent on manufacturing that component. That is something which gives you a clear view of what are the optimizations that have to be done for doing a better production. Okay? And hence, answer the most critical question, production versus wastage. Another example is on shop floor energy management. Now here, in most of the industrial cases that we have been speaking with most of the top industry guys, a common problem statement that comes out of the industry is they do not know what is the energy footprint. They do not know where is the energy consuming. A typical SME gets a bill, he pays that electricity bill. He doesn't know where is the energy getting consumed. What is that bifurcation of utility? What is the bifurcation of actual production requirement? What is the equipment really consuming? Is it really consuming what it requires? How does it map with the production? All of these questions get answered with a simple solution of adding a smart meter with a communication capability at every critical energy consumption points. The moment you have an energy meter in there, you have a centralized dashboard which gives you a complete detailing of where and how the energy is getting consumed. And then with analytics, give you further optimized aspects to better your overall consumption footprint, right? Wow, we are in Bangalore, so I'm from Pune. All of us know the issue of parking. Very critical. So yes, IoT is something which can be applied for parking automation. We are working on some of the parking automation cases where you have battery-operated sensors with electromagnetic or ultrasonic sensors which are tracking the existence of a vehicle at a parking slot. With the addition of localization into it, we know the power of localization with Uber and Ola. It gives convenience to the users wherein you can actually get it on your mobile, which is my free slot. As a service provider, you have better usage and monetization of the whole parking management solution. Overall, globally, all of us know we are moving, and there are a lot of programs that are running on LEDification. The core of that whole thing is at energy saving, right? With LEDs, yes, energy gets saved. What more? The more important aspect in here is to have an ability of centralized monitoring and conditioning system to be able to know, am I really saving energy? Are there burners that I need to control? Can they be automated? Right? Can I have a better SLA of my whole street lighting automation system such that I get to know what are the actual field faults that are happening? Yes, the answer is having a centralized, controlled, and monitoring system, which is a IoT enablement for a street lighting application case. At Maven, we have been implementing this solution. We have some deployments across the globe. One of the recent deployments is in Aligarh. We are monitoring and controlling more than 15,000 streetlights there. What you see in front of you is a Google Map integration of actual location where we are doing it. Smart grids, AMRs, AMI, heard of? Heard of? Yes. Let's talk a bit more on application of IoT into all of these areas. This is one implementation case that you see in front of you, which is a very good example of hybrid mix of technologies. The technologies that we spoke about, each one of them has a different flavor. You need to have a right mix of these to have a success story. What you see here is a very good example. At the last mile, you would see Zigbee-enabled interoperable meters, which helps third-party multiple meter providers to enable a solution. At the second layer, you see there is a usage of sub-1 gigahertz radio technology, right, which is enabling much larger penetration across concrete. Okay? At the third layer, you're seeing a GPRS or a WiMAX-based connectivity to the head end, right, which is for longer range. Once you have two-way connectivity down to the meter, what you do is reap the benefits of a AMI. Reap the benefits related to billing, reap the benefits related to capacity planning, demand response planning, right? Peak load management. The moment you have a control and you have the real-time reliable data coming in, all of this becomes possible. This is one implementation case, around 6,000 odd meters that we have automated. This is how the network looks. So you can see it's a very robust deployment and a lot of, you can see actual mesh network implemented on the field. A lot of redundancy into the network. So even if one of the nodes goes down, it is not affecting the network. Furthermore, on the smart grid side, you have substations. Substation monitoring is coming across as a very critical aspect because there are very high-cost devices into all of these substations. Performance and productivity and health monitoring of these devices is a critical piece for having an efficient grid. Okay? One of the application cases, we have deployed a solution for circuit breaker monitoring in Khopoli. Okay? The solution provides real-time performance monitoring. Also, with analytics, provides predictive analytics for the life of the critical device like a circuit breaker. Okay? Another area is transformers. We hear a lot of T&D losses, and an average loss in India is around 25%. It's no different in developing countries elsewhere. So globally, we see T&D losses coming as a very important piece that needs to be worked upon. Okay? One of the core areas there is to have an efficient transformer monitoring system, which gives you the performance of the transformer. One, it helps you to understand the life of the transformer, gives you alerts, alarms to have a better SLA on the transformer side. Right? Taking it forward to renewables, we are doing some implementations on renewable energy monitoring. On the renewable side, again, equipments, monitoring the energy footprint, trying to understand what is being consumed, what is being generated, right? Also, what is being transmitted, okay? Getting all of this along with the health of the whole plant. We're deploying some solutions in the area and then taking it forward in the next phase for a microgrid implementation. With renewables, a microgrid IoT-based implementation is the key. And yes, we are working on a few cases to enable the same. Very core at heart, smart farming. I've been hearing about this topic since yesterday multiple times. People trying to see and understand what IoT could really do in the oldest industry in the world. Yes, multiple cases to have automation done on the farming side. With the power of IoT, getting feeds from third-party systems to make the right decision making. So, having possibilities for automatic irrigation, precision irrigation, are some key areas which would be helping farming. Very suitable for contract farming. We are working on a few cases for almond farming in Canada, which requires a lot of precision data sensing, decision making, to increase the overall productivity of the whole farm. I heard one of the speakers saying yesterday, the biggest problem is productivity and yield out of a 1 acre farm is much less in India. China is doing it 3 times more. Yes, you could optimize it with the right technologies implemented, with the right data available, and then synchronizing that data for the right decision making with IoT. Okay. I'm happy to have a tiger on my screen. I see charged up faces. The application case is for wildlife monitoring solution, wherein you have a wearable device monitoring vital parameters of an animal. What is his heart rate? Where is his location? Okay. Getting all these vital parameters with real-time stamps, sending it over the ecosystem, again to a head end with cloud and analytics, which does important data analytics to give sensible data for decision making for the stakeholders. Okay. Now, having such implementations will really help us to have a better wildlife conservation program. Logistics is one area where globally we are seeing a lot of applications and first steps being taken for implementations. One of them here that you see is into asset tracking. A very refined case there is for logistic monitoring for cold chains, wherein you're transmitting or transporting perishable goods like your vegetables, fruits, ice creams, or high-value injections. You want to know where they are. Are they being transported at the right temperature? If not, the quality degrades. Okay? So having a logistic IoT-enabled supply chain management helps you have a better outcome. Okay? We are working on a few cases of these. I would be happy to discuss them when we meet in person. This is another core area of deployments now into heavy equipment monitoring. So equipments that go into construction, mining, into refineries, into areas where the environment is not so good. You need a robust device to work in there. Also, connectivity is an issue. You do not have a GPRS always available into a mine. So we have been implementing real-time performance monitoring solutions into such kind of equipments and areas. Another teething problem with most of the ULBs that we have been speaking with, the problem statement is well known. Of waste management, how do we really have an efficient solid waste management system? The answer to it is having a smart bin with sensors embedded into it, and then coupling it into an ecosystem with logistics, okay, to have an efficient solid waste management system. Again, working on a few cases in these areas. Smart cities with the Smart Cities mission is one of the hottest topic. I would say at Maven, we have been working on multiple cases. All that we spoke about in the last few slides, all the technologies that we spoke about, this is an implementation when all of these get applicable. At Maven, we try to look towards a smart city implementation as an infrastructure solution. More of an infra solution wherein lighting management will be at the base of the whole implementation of a smart city. The reason, in any city or a ULB, the largest asset or widespread asset into that city is its street light. You have a street light at every 30 meters on the road. The moment you are able to have an infrastructure to make that every street light communicable two-way, the possibilities are endless. You have lighting, you have parking, you have vehicle. In the same networks, you add other applications and cases. So the kind of solutions that we are enabling onto the street lighting, onto the smart city solutions are all with a base network for last mile connectivity on which you can go on adding multiple application cases. This is a snapshot of few of Maven's deployments in India and globally. Well, we are a MOSchip group company. We spoke about it, which is part of TechWave Group USA. Thank you. I would be happy to answer questions. Thank you.
Could we have the mic, please, over there?
Which is the best this connectivity technology for sending data from water to air?
From?
Water. From inside water.
Inside the water to?
Air outside. Outside the water, if I want to send some data, which
Right.
is the best technology?
Okay.
In
So-
terms of power and this range, like water body, like swimming pools or seas, if you will take examples, means which is the best technology?
Okay. I would say the applicable technology in there would be more of a sub-1 gigahertz instead of something like a 2.4 gigahertz. Because by law of physics, 2.4 gigahertz gets affected by humidity, right? A sub-gig has less impact with water and less attenuation when it's communicating through water. So a right choice to be tested and used in there would be, if you need a battery-operated solution in there, would be something like a LoRa. To have a battery-operated solution in there and transmit it over sub-1 gigahertz, and you have multiple ISM bands across the globe, which are de-licensed on the sub-gig side.
My question.
Last question, please.
What's the cost of the smart meter that you talked about? You talked about primarily in the industrial scenario, right? So what's the kind of cost that we are looking at to install a particular smart meter to measure the power consumption of the particular machine? That's first question. Second question, again, the cost factor. For the street lighting systems that you talked about, that's the backbone of a smart city. What's the kind of the cost for installing that unit? Because finally, we all talked about the cost that's going to the customers, and what's the cost that that your company is targeting per unit?
It would be totally unfair for me to talk about cost because I would have all my competition bouncing on me. Let me answer it differently. For all of these solutions, typically a ROI or a break-even should come in a time frame of around 2 to 3 years, at least 2 years. 3 years still higher. Typically in 2 years, you get a break-even for all of such implementations, be it street lighting, be it into utilities as well.
But again, that depends on the number of units you've installed, right? So at least you have to give us a range. I mean, for 1 million units, it's 2 to 3 years, or 10 million units. Something like that?
Not really, not really. It's, with our experience of implementing IoT, the cost and the ROIs, we have been seeing more of getting standardized, starting from an implementation size of 100, okay? And that's actually true. Rather, when you go on increasing it, it tends to fall down. Because there are different ways of implementations of these technologies. I'll give you a short, quick example. Probably we are running short of time.
Please, just a very
in an
quick piece, please.
industrial scenario, you have RS485 enabled meters. What you do is you daisy chain 30 of those meters and just add one IoT device, right? So you're not spending onto 30 devices for getting the data. Okay? So there are different ways of implementations to have the right ROI, the right break-even to come out of the whole implementation. And that's where the key lies.
Right, okay.
Thank you.
So, thank you, Anurag. Could I request Rajesh to come on stage? Rajesh is our Executive Council and Board Member for ISA to give a quick memento to Anurag.